question 1, we have been given a small set of data and we're asked to calculate a range of different measures. So our sample size is 7 and we've got the values 12, 7, 4, 9, 0, 7 and 3. We'll do the mean first. So the mean is going to be x bar, and we just need to add up the x's and divide by our sample size. So it's going to be 12 plus 7 plus 4 plus 9 plus 0 plus 7 plus 3, and we divide all of that by 7, and that gives us 42 over 7, which is 6. So the mean is 6. Now we have to do the median as well, but for the median we have to find the position first. Now the position, we can use our formula. It's just n plus 1 divided by 2. So it's going to be 8 over 2, which tells us it's the 4th position. Now we have to have the data in order, so we can do that. Our smallest is 0, we've then got 3, 4, 7, 7, 9 and 12, and don't forget just to count up and make sure you haven't missed anything. Once we've done that, we can simply count our way through and find the 4th. So 1st, 2nd, 3rd, 4th. So the median is equal to 7. Now our last measure of central tendency is the mode, and that's what we've got to calculate next. So let's just go in. Okay, so for the mode, it's the most frequently occurring value. So the mode, simply by looking at that ordered data, we can see that only 7 occurs twice, so that's our mode. Now we've also got to have a look at the quartiles. So for Q1, we start off with the position, and that's just going to be n plus 1 over 4. So 8 over 4 is the second position, and using our ordered data from the previous slide, we can say that therefore Q1 equals 3. It's just our second value. So for Q3, we need to firstly work out the position. It's going to be 3 times n plus 1 over 4, which will give us 24 over 4, which tells us that we're looking for the 6th position. And if we count along our ordered data, that leaves us with 9 as our 3rd quartile, our Q3 value. Okay, so that takes care of our 3 measures of central tendency, as well as Q1 and Q3. We then have to move into our measures of dispersion, and we can start off with variance. Now if you're doing these by hand, you work out variance first and then standard deviation. If you're working in Excel, you'd be looking at working out standard deviation first and then working out variance. So our formula for variance of a sample is just that s squared, so that's our symbol. Now we've got to go through and we've got to get each x, we've got to minus the mean, they all get squared, add them up, and we divide by sample size minus 1. So it's pretty much just a matter of going through and working on this formula. Now we've already worked out the mean, and it's 6. So to work out s squared, we would take our first data value, which is 0, we'd subtract the mean, and we square it. That's our first squared deviation. Now that's going to be added to the next data value, which is 3, minus the mean, and we square that. Next data value is 4, minus the mean, we square that. Next data value is 7, minus the mean, square that. Next data value, 7, minus the mean, square that. Now running out of space, I'll do my ... trick, but it would just be 9 minus 6, square it, then 12 minus 6, square it. And that of course all gets divided by n minus 1, which in this case is 7 minus 1. Now if we put all of that into our calculator, we end up with 16. So our variance is 16. And we can then work out standard deviation because we know that's just going to be the square root. So S will just be the square root of our variance, which will be the square root of 16, which will give us a result of 4. Okay, so now we can work out our coefficient of variation. Go to a new screen. Now CV is just a way of turning standard deviation into a percentage of the mean. So it's just going to be S over mean. That gives us a decimal. We can multiply by 100 if we want to turn it into a percent. Now we've already worked out both of those figures. So standard deviation was 4, sample mean was 6. That gives us 0.6667. And if I multiply by 100, that's 66.67%. So that's our coefficient of variation. Now we also have to do our range and our interquartile range. Range is just the maximum minus the min. Our maximum is 12, minimum is 0, so we've got a range of 12. And in terms of our interquartile range, well, that's just Q3 minus Q1. We've got each of those values, so Q3 is 9, Q1 is 3, so our interquartile range is 6, and that just represents the spread of the middle 50%. So that takes care of question 1.